going to say. Okay, go ahead.
Thank you for coming to this UN Ocean Decade Clean Ocean Lab satellite event, Observing Air-Sea Interaction Strategy, or Oasis, for a Clean Ocean. I'm Krista Marandino, and along with Megan Cronin and Seb Swart, am a co-chair of the Oasis Score Working Group, and we are taking a systems as a whole approach for making surface and boundary layer observations that are relevant to Earth's energy, water, and biogeochemical cycles. Oasis was endorsed as a UN Ocean Decade program and has teamed up with the Surface Ocean Lower Atmosphere Study, or SOLAS, to convene this satellite activity. As we all know, the human footprint is reaching historically pristine places, such as the open ocean. I show you here just a few examples of this: the spread of surface ozone pollution, the occurrence of harmful algal blooms, and the reach of the global shipping industry. These topics and many others have a key air-sea interaction component. And this UN lab is a crucial but relatively unique opportunity to allow for the air-sea interaction community to reflect on how our traditional scientific topics interface with ocean pollution and hazards. To facilitate this process, we have convened this program with the aim to develop a roadmap for how observations and understanding of air-sea interactions can support a clean ocean through the use of community discussion. This community discussion should include as many stakeholders as possible. This event has 3 sessions with associated main questions. The first session is about impacts of marine pollution. We ask here, what are the effects of pollution on air-sea biogeochemical processes, harmful algal blooms, and other processes? In session 2, we look at the techniques used to observe and understand marine pollution, and here we ask, what are the observational, both remotely sensed and in situ, and model tools used to support a clean ocean, and what's missing? In session 3, we explore an Oasis strategy for a clean ocean. We ask, what specific steps should the UN Ocean Decade Oasis program take to support a clean ocean? We hope to engage you all in discussion on these topics here today and try to use this discussion to develop the roadmap for Oasis, SOLAS, and other air-sea interaction interested folks to move forward. At the end of this, we hope to summarize the main action items for this decade and beyond. So one final point to support the discussion on Oasis for a Clean Ocean. This is our Oasis organizational chart showing how we seek to work with community members across 5 theme teams. Each of these themes, developing the network and model design, capacity building and sharing, the UN Ocean Decade, best practices and interoperability, and fair data, model, and Oasis products can be tapped to support a clean ocean. But we need engagement from the community to help us learn how. And before we get on with the event, I would like to say thank you very much to the organizers, moderators, and speakers that made this event happen. You can see them all here. Also, please remember that there are 2 airings of this event on the 18th of November at 1700 CET and 19th November at 2 o'clock CET. There is a poster session and a networking activity in Gathertown for 1 hour before and after both airings. Please stop in and visit the posters and meet with your colleagues. There's a link and a password posted in the chat. So I hope you enjoy this event, and thank you.
Yeah, hello everyone. Thank you, Krista, for the pre-recorded introduction. My name is Dennis. I'm a marine chemist working at GEOMA in Kiel in Germany, and basically looking for the influence or investigating the influence of ship emissions on the production of biogenic trace gases. So today, first of all, welcome to the first session. The session is called Impacts of Marine Pollution and Hazards. And we have 2 speakers, again, pre-recorded speakers, which are namely Matthew Jones and Lydia Lada. So Matthew is from the UK and Lydia from Mexico. And we will first listen to both of their talks. And afterwards, I'm happy that we have a nice discussion about their projects they will show us, but also like in general in terms of the impacts of marine pollution and or hazards. So then I would like to ask whoever, sorry, I forgot who's responsible, but please You can start with the sharing. Thanks.
Hello, I'm Dr. Matthew Jones. I'm an environmental analytical chemist currently working in the Wolfson Atmospheric Chemistry Laboratory at the University of York in the United Kingdom. My short talk today, entitled A Clean Ocean, Nature's Advanced Oxidation Processes, will introduce how there is a balance in marine and atmospheric systems as they interact to essentially produce a self-cleansing system. Advanced oxidation processes is a term coined by chemical engineers for a large suite of reactions used during drinking and wastewater treatment. Reactions typically involve a strong oxidant with and without UV light acting on harmful substrates, for example, toxic bacteria or organic and inorganic pollutants. However, these processes are only echoes of what occur in nature. Many of these processes are studied in the atmospheric sciences and microbial and molecular biology. Atmospheric chemists have shown how advanced oxidation processes are essential in the environment and affect redox-sensitive species, while microbial and molecular biologists understand these processes in terms of organic material recycling and detoxification of reactive oxygen and nitrogen species. While what we can suppose is that over billions of years, any marine biota has evolved to harness the effects or conversely nullify advanced oxidation processes. Why? Because in and around shallow marine systems, UV light is present, and so too are the oxidants ozone, hydrogen peroxide, manganese oxide, and nitrite. This supposition suggests that there is a positive yet balanced outcome for microbiology and their oceanic environment. Of all the marine environments, there is one that is optimized towards advanced oxidation processes. This is the sea surface microlayer. The microlayer is the marine environment that we know the least about. Though it is the most accessible, it is also one of the hardest to sample, making it an excellent choice for laboratory studies. The microlayer is the ocean-atmosphere interface, and as an interface, it controls feedback processes. The organic-rich nature of the microlayer means it has a unique reflective property. The layer is also a source of particulate aerosols, while simultaneously disrupting gas transfer fluxes into and out of the ocean. Importantly, reactions therein have consequences that can be traced both deeper into the marine environment and back into the atmosphere itself. One process controlled by the sea surface microlayer is the removal of lower atmosphere ozone. This removal process has significant feedbacks to both the atmosphere and the marine environments. Reactions of lower atmosphere ozone at the surface microlayer produce strong climate feedback. Ozone will react with iodide, and through a reactive intermediate species, hypoiodous acid, or HOI, produce volatile iodine species that are cloud condensation nuclei, hence the climate feedback. This reaction also reduces any harmful lower atmosphere ozone concentration and provides a source of the essential human nutrient iodine. However, the reaction of ozone also releases a cascade of reactive oxygen species into the marine environment. Reactive oxygen species including hydrogen peroxide. This cascade of reactive oxygen species leads to a range of advanced oxidation processes. The ozone iodide reaction is a balanced self-cleansing ocean process, but it is likely this balance is shifting. Ozone uptake by iodide is inhibited by the buildup of anthropogenic surface active molecules and reactive to ozone, those such as polyfluorinated alkyl substances or sodium lauryl sulfate. Atmospheric nutrient deposition acts to increase the marine biomass, but this increase results in extra organic material fluxing to the surface microlayer, and this provides competition for iodide towards the ozone, while the addition of reactive chemical species disrupts the reactive oxygen species cascade through the marine environment. The atmosphere and marine environment has an ability to self-cleanse, but as we overload the system, the benefits of this self-cleaning balance are removed. The results are that the availability of an essential human nutrient decreases. The oceans find it harder to check the spread of toxic and dangerous chemicals, and the likely effects of cloud formation may be huge, but it is yet unknown.
Hello, my name is Lydia Lada. I am at the Department of Biological Oceanography at CICESE, located in Ensenada, Baja California, Mexico. I've also recently been developing the RSEC Alliance, which stands for the Alliance for the Restoration of Coastal Ecosystem Services. And on this alliance, we collaborate with many different NGOs and private sector companies, as well as many scientists and social scientists. Many of these communities are stakeholders along the Baja California Peninsula that are severely concerned about the coastal impacts of the algal blooms on this coastline. So the Baja California Peninsula is a biogeographic transition zone between warm, temperate, and tropical, subtropical waters, and therefore it's severely impacted by climate change impacts. This coastline is dominated by kelp forests in the north and coral reefs in the south. Many of these ecosystems provide very important ecosystem services, such as fisheries, to much of the local rural coastal communities. These local coastal communities depend very much so for their livelihood and for their cultural identity on the benthic fisheries associated with some of these coastal ecosystems. However, they are seeing an increase in both the frequency and intensity of harmful algal blooms and the hypoxia that's associated with them. The coastal benthic marine fisheries, such as lobster, some fish, some octopus, and of course the highly valued abalone, are severely impacted by these HABs and by the hypoxic events that occur alongside with them. And these have huge socioeconomic and socio-ecological negative impacts. Now, one of the NGOs that is highly involved with these fishing communities is COBE. And this slide was shared to me, with me by Magdalena Procoma at COBE. And what COBE is doing with the Federation of Cooperatives is monitoring these hypoxic events and empowering the local communities to put in oceanographic sensors to then understand more about how and when these hypoxic events and these red tides occur, to then empower them for local decision making. And what they're doing is they share the data through WhatsApp, and what they would like to do is take this a step further and create an early warning system. And the idea of this early warning system would be if any one of the cooperatives detect either a hypoxic or a red tide event, they could then share this information with surrounding communities before they're actually impacted, so that they can either adapt or mitigate their fishing systems beforehand. Now, what RSEC is trying to do is link this kind of approach with some of the work that's being carried out in Southern California. And what we wanted to do was to bring some of these issues that the fishing co-ops and the marginalized communities along the coast of Baja California are having and are seeing, so that when we start to talk about approximating some of the solutions to some of these impacts, that we can take into account some of these marginalized communities so that we can undertake the understanding in a more equitable fashion. So RSEC is bringing to the table this impact in Baja California on all our different stakeholders, with the idea that some of these issues also need to be considered when we talk about solutions. So I'll stop there, and I thank you very much. And I can be contacted at CISESE whenever necessary, and Magda can be contacted at COBE.
So these were the two very short overviews, very different topics, still pollutants, but two very different topics. And I see that at least Matthew is here. So in the first chance, if you have any questions, please raise your hand according to his presentation. Lydia is also here, I see. Yeah, I have not them all. So if someone has any question about one of the talks we have just seen, please raise your hand. So no questions? Krista has a question. Ah, no, Krista. Okay, Charles. Please unmute yourself. Yes.
Hello. Hello, everyone. Can you hear me?
Yes.
Hello, yes.
Okay, my name is Charles. I'm from Nigeria. I'm presently a PhD student in Xiamen University of China. So my question, I don't know who's going to reply me since like the just finished speech was like a prerequisite speech. So, but my question goes anyway. I wanted, if the speaker was available to answer, like I wanted to ask, like if there's any like mitigation method already in place. Like presently in China, I think they developed like method using clay to like mitigate the effect of like this harmful algae blooms. So I just wanted to know if there's any of such a method applicable that can be used in like the environment where this harmful algae bloom is like occurring. So that was my question I wanted to ask.
So just to confirm if I got it right, so you were asking if there are kind of ways to prevent these algae blooms, or?
Yeah. I think there are sustainable ways like that have been tested and trusted based on like the science, you know. So and they use the clay, like some use the natural clay, and probably some have engineered or done some like engineered work on it. So when this clay is like it's like sprayed into like the marine environment, like the environment affected by these harmful algae blooms. So it's able to disperse and reduce the effect, the toxic effect in the marine environment. So I was just gonna say that ask if there's any of such operation going on within the environment where there's this occurrence of the bloom.
Yeah, so I think perhaps Lydia might answer these questions. Otherwise, Matthew has raised his hand. So please, Matthew, go ahead.
So shall I go first, or shall we let Matthew?
Yeah, sorry. Yeah,
okay.
I didn't see you.
Before my kids interrupt me again. So I think that's a really important question. And I think the ability to detect these impacts rapidly is incredibly important for a lot of at least the rural communities, and obviously in the cities too, with some of the bigger stakeholders. And I know what we're trying to develop in collaboration with what's going on in California is to detect quickly and then respond rapidly. And there's all kinds of different types of mitigation and adaptation responses. And another one that we're trying to encourage is to get the community to think about diversification so that they can put in these protocols quickly when either there's a toxic event or there's an oxygen drawdown associated with some of these blooms, and then respond. For example, if they're fishing abalone and they see it coming, they can harvest their abalone if it's harvesting season and not wait. They can harvest their entire quota quickly before the abalone that they're going to harvest die. And then another thing they can do is we can then start thinking about repopulation efforts. We can start thinking about restoration efforts. You know, they're not all sponsored to help repopulate, especially if there's some mariculture initiatives in the area. There's spillover. We can larger organisms, get them into the water, so that they at least have something to harvest, and that there's
Lydia, sorry, your sound is going down.
Let me see. Can you hear me now? I think I had my hand over that microphone. But the tuna farms move their tuna pens when they know that there's an impact, things like that. So there's a lot of things that can be done, but it's key to understand when these impacts are occurring and be able to respond rapidly. And that's where an early warning system sort of comes into play. And that's where we sort of need to tie in to sort of the large scale collaborative efforts so that we can all be aware. And then each community is obviously going to have their own independent mitigation and adaptation. I know nothing about clearing. I think that's really interesting. I've never heard about that, but being able to actually clear a red tide, I don't know about that. But adapt and mitigate, yes, that's exactly what we have to do.
I think, Charles, this is answering your question quite well, right? I think Charles, yeah, he's still there. Matthew, do you want to add something to this?
Okay, can you hear me okay?
Yes, perfect.
Yeah. So I was just going to say, there is quite a bit of modeling, for instance, on red tides and formation of red tides, but there is work by biochemists and biogeochemists which look at chemical compounds produced by phytoplankton species, whether these are organic or inorganic compounds, and these compounds induce blooms to erupt or collapse. So for instance, one of the signaling, you have various chemical signaling compounds. And I've heard of some research where they look at these organic or inorganic compounds to see if they can control the bloom, either at the point of before it erupts or some other time, to induce these blooms to collapse. So there are potential in the future inorganic, organic compounds that can be used or could be used to disrupt the formation of certain toxic algal blooms. So yeah, potentially there is work that is done in the future for this, and it is possible.
Yeah. Okay, thank you, Matthew. Any further questions to the talks itself?
Megan?
Yeah, thanks. So Lydia, could you describe what variables you were measuring to detect these events?
Yeah, so mainly we look at oxygen, and temperature, and try to understand what the physical factors are that relate when these events occur. And then another thing we can do is we can take samples, we can take water samples and send them to laboratories for analysis. We don't do the analysis, certainly not in these rural communities, of course. But it could be really interesting to tie into sort of the larger scale collaborative effort. With our physical and oxygen data to then understand when they occur, how they occur, at least at our smaller scales.
And what depths are those oxygen measurements?
We're on the shelf, of course, where they're sampling. So we're within 30 meters and shallower.
Okay, thank you.
So just to add on this, Lydia, so you mentioned that you give the possibility also to the population to have like their, if I got it correctly, their handhold measurements or just their synopsis to put it somewhere on. Is this also oxygen measurements, or is it just temperature or salinity, where they can, what you mentioned, like with this 20 small measurement, individual measurement technique?
Are you asking me what's going on in Mexico?
Yes.
Yeah. Yes. There are oceanographic moorings that we can put in the water that are downloadable on Bluetooth. The problem is that a lot of these communities are extremely rural and have no access to internet, but they can communicate with their phones. And one of the things we just actually talked about this morning was to try to get funding to provide tablets and internet nodes, sort of satellite internet nodes in some of these communities, so they can then upload their data and start to communicate with each other, and then obviously communicate with the larger community, along the entire West Coast of North America. So that's sort of our interest. And, we're right now we're looking for funding and trying to get trying to help as many of these rural communities as possible, because their entire livelihoods depend on these systems being healthy.
Thank you.
Thank you very much.
Matthew, I have also one question.
I just wanted to ask another question again. So,
okay. Please go ahead.
Okay. So I wanted to say, like, the measurements you guys are taking, is it like what's the interval? Are you taking measurements daily or weekly? And also, like, is there any like pre-existing data on like the biochemistry of the area? Like, when did this project start? The project of like sharing the data, like when you measure and try to detect the events, like when did the project start, and how often are your measurements being taken? Like, what's the interval?
Right. So these are high frequency oceanographic measurements. The problem is that in a lot of our applications, they are moored. So you have to sort of pull them up and download. The fishers go to sea every day that that conditions are safe for them to go and fish, and they dive to collect abalone with a hookah, with sort of a hose and a compressor on board. And they can also put these instruments on their pongas, on these small skiffs when they go to sea, and get the data that exact same day when they can download the instrument. So that's another thing that we're sort of thinking about, is that unless we have rapid measurements, we can't respond rapidly. Like, pulling these instruments up once a month doesn't help us respond. That would certainly help with modeling in the future, but we really need sort of immediate or near real time information to be able to respond. So that's what we're trying to encourage right now. Problem is that these probes are expensive. And, obviously these communities can't afford to buy them. So the idea is to provide them with a sort of technological package that they can then use, and then provide capacity building and have influencers in each community that can then push these ideas forward, so that some of these fishers could understand the importance of doing this. And once they start to see financial feedback, of the benefit of doing this, then hopefully these projects will become sustainable on their own once we have the initial startup funds. I hope that answers your question.
Can I want a clarification here. So you're saying that the issue is getting the data from the sensor, and that you are using Bluetooth, or that there's not some kind of telemetry system? That's what's missing.
Yeah, well, these are communities that don't have electricity, so forget about anything that's these are very rural communities isolated along the Baja California coastline. So they can communicate amongst themselves, but they can't get the information out. So if we can have these sort of nodes, these internet nodes, where they can then share the data over. And there's a system now in Mexico where the local phone company provides internet, just satellite internet, in places that have no phone service. These are people that don't even have phones. There's no phone service there. There's no phone, there's no internet, there's no electricity in a lot of cases, unless there's like solar panels and stuff. So yeah, there's all those limitations that we're working with. But if these communities can monitor themselves and detect these impacts fairly quickly, then they can respond, and they don't have to depend on all these other impacts. I mean, the work that NASA's doing, and that NOAA is doing, and that SC Cruz is doing is spectacular, but these communities don't know about that stuff. So trying to link them all together is sort of where our alliance is trying to bring this information together. Obviously, with some of the great NGO works that we've been working with.
Hey, Lydia, it's Clarissa. That was an awesome response. You made me think so deeply about this, because in the SCOOS world, as you mentioned, we're trying so hard to develop apps and thinking about apps. Oh, every person who's on the water and only has a cell phone, at least in the US, could benefit from an app because they often have a harder time just accessing web browsers and don't often have computers at home. But you're bringing up a whole nother layer of complexity with people who don't even necessarily have electricity, which is just something we haven't contended with at all here.
Right, right. I mean, you know, we do the best we can. There's solar initiatives that, you know, and things are changing slowly in some of these rural communities, but not fast enough to benefit their livelihoods. I mean, think about all the other impacts, whether it's education, whether it's outreach, you know, besides all the networking that's important. So yeah, we're doing the best we can, and they're our partners, and they've come to us with these needs, and we're trying to sort of co-construct these solutions in this transdisciplinary way where, you know, the anthropologists are involved, the social scientists, and the oceanographers to try to solve some of these problems for these people.
Yeah, sounds really interesting, and seems like much work in terms of not scientific way, but also on a, yeah, even when think about no electricity is there. So it's really interesting.
Right, the social challenges. But if you think about how important that data is to link together for some of the modeling work, I mean, these are critical environments, these are critical ecosystems, and understanding how they're impacted completely links in with some of the larger scientific questions as well.
No, right. Okay, I think we are almost 35 done. So yeah, thank you for the discussion. And I think we will now have a 5-minute break. So just grab a cup of coffee or your after work beer or whatever, which time zone you're just in. And then we meet again in 5 minutes at 5:40 CET back here in the Zoom room. Meanwhile, you can also check out the posters. So they are really interesting posters out there in GatherTown. And I think the link was posted here in the chat. So thank you for Matthew and Lydia for your talks, and see you in 5 minutes.
I suggest reposting the GatherTown in the chat, since whenever people join in late, you don't see it again. You don't see the original chat.
I'm going to go into the notes just FYI. Actually, so Jesse, were you taking notes the whole time? Thanks, Dennis. That was good. Were you taking notes?
Yes, I was taking notes for take home.
As our 15 and 20 minutes. So our next session moderator is Ebenezer.
Hi all, good morning, good afternoon, wherever you are, any part of the world, and thanks for joining us again. So welcome to the second session of our event. And in this part of the session, we'll be looking at techniques that we can use in observing or understanding marine pollution or hazards. We have very rich tools that we use for ocean observation and process investigations. So what we want to deliberate on and learn more about is whether we can leverage any of these tools to study marine pollution. And we have 3 very interesting talks. And after that, we go into discussions and then take some notes, brainstorm, and then see the way forward. So if we can please have the first video.
Hi everyone, my name is Morgan Pirin. I'm a postdoc researcher at the University of Tasmania in Australia. Thank you for the invitation to the Oasis workshop for a clean ocean. When we talk about ocean pollution, most of us can picture the image of a plastic bag floating at the surface of the ocean, or a glass bottle down the seafloor. But these are just the visible aspects of ocean pollution. Today, we're going to talk about one invisible aspect of ocean pollution, which is heavy metals. Heavy metals, highlighted in red here, are natural elements present in the Earth's crust. Everything isn't all bad about heavy metals. as some of them, like iron, cobalt, and manganese, for example, are vital for marine ecosystems to grow healthy. On the contrary, other metals like mercury, lead, or nickel, for example, can be heavily toxic for marine life as well as for human if absorbed in high concentration. Heavy metals can enter the ocean by riverine discharge, sediment on the seafloor, and hydrothermal vents. They can also be deposited to the ocean surface in the form of aerosol particles and rainfall. Atmospheric sources, which are rich in potentially toxic metals, include natural fire emissions and volcanic eruptions, as well as human-induced emissions from industrial activity, traffic, household heating, pesticides used in agriculture, and shipping emissions. Following transport within air masses, heavy metals fall onto the ocean surface, and that's where they can cause harm to marine ecosystem. Due to their low concentration in the environment, heavy metal analysis in seawater and in atmospheric particles requires stringent laboratory processing and high-performance analytical instruments. For this reason, they cannot be directly measured using autonomous open ocean moorings or profiling floats, and they cannot be observed using remote sensing tools. Seagoing expeditions enable the simultaneous collection of seawater, aerosols, and rainwater in order to measure heavy metal pollution in the marine environment. However, shipboard campaigns are costly, and they only offer a restrained vision of the state of health of our ocean at a certain time and a certain location. The time series aerosol sampling station of Kunani on the island of Tasmania, Australia, is another great example of a scientific tool which is deployed to monitor heavy metal pollution in the atmosphere prior deposition to the ocean. While the station is set at a fixed location, it enables continuous monitoring of the heavy metal content of the atmosphere over a long period of time. The strategic location of Kunani Station at the Southern Ocean's gateway and downwind to one major air mass transport pathway of Australia offers a unique opportunity to capture the signal of episodic and unpredictable weather events like fire emission, which are otherwise very difficult to investigate. It also enables to witness period of enhanced atmospheric pollution due to human activity, like shipping, for example. The Kunani station is located in a fairly remote place where pristine air masses often dominate the atmospheric loading. Monitoring heavy metal content in the atmosphere during background or unpolluted air condition can then help to better assess the magnitude and significance of higher atmospheric pollution periods. There are currently very few stations which are continuously measuring heavy metal pollution in the atmosphere or in the ocean, and I believe that time series stations are powerful tools to pinpoint prevailing sources of heavy metal contamination to the global ocean in order to implement new policies around those emissions. Thanks for your attention, and thanks to the IMAS biogeochemistry team down in Hobart.
Hello, my name is Natalie Mahod. I'm a professor of atmospheric science at Cornell University. Today I'm going to talk about the atmospheric part of the microplastic cycle using a set of observations, an amazing set of observations that Janice Brainey and her co-authors published in Science last year, focused on the Western United States national parks and in rather mountainous regions. They detected quite a bit of microplastics in these regions that were coming from long-range transport, but not from local contamination. And so we put these into a model and deduced some of the different sources. We considered tires and braking as well as highway sources, an ocean source, just assuming microplastics at the surface of the ocean can be entrained into the atmosphere, agricultural dust and other dust downwind of population centers, as well as population centers. And so what we do, these are details here for the model comments, but what we do is we model a source and do the best we can with the temporal relationship of the source strength. And then we look at the transport to the deposition. So we look at the exact same time that the observations were made in the deposition. And so the model connects those two, assuming some source. And then we raise and lower the magnitude of the source everywhere based on that relationship. So we use an optimal estimation method, which also gives us information about the 95% confidence limits, for example. So what do we get? Well, we find in the Western US, most of the contribution comes from the road tire source, but the ocean source is not trivial. It could be important with a lot of uncertainty. And some of the other sources, ag source, dust source, and population sources. So these are roughly consistent with what little data there is, but really these all need to be better refined. Here's some comparisons, some illustrations of what we get. That here's the total microplastics from road sources, ocean sources. You can see the ocean sources are going to deposit right nearby for the most part and not make it to our observational sites. Ag dust, population dust. If we extend this globally, we get something really interesting, which is that the road source is still there and it's consistent with the literature that's there. But the ocean source might be huge. It might be between 0 and 22 teragrams per year. About 8 is our best estimate, 8.6. So that's quite a bit of aerosol. So black carbon from anthropogenic sources is about 10. So that's a huge amount of microplastics into the atmosphere. And the other sources are also large. So we think about what's happening globally. There's a whole lot of source and sink over the ocean regions of the microplastics there. And then some of the ocean source gets on the land and some of the land sources then get out into the ocean. And you can see that segregated here in this plot. The ocean concentrations that we are assuming are really quite small for the size. We're between 400 and 300 microns in size that we're taking a look at. And so up to 50 grams per kilometer squared, whereas the observed plastics in the less than 5 millimeter size fraction is up to 50,000 grams per kilometer squared. So it could be larger potentially, but what we're deducing is a kind of a reasonable number of the pollution in this size. Overall, what we're getting in this study represents the first time that anyone has looked at the ocean source of dust in a model, tried to take a look at what could be happening, or I'm sorry, not of dust, of microplastics and all the other sources of microplastics. And we really come up with more questions than answers, but it looks like the resuspension of microplastics from the ocean into the atmosphere could really be an important process. Thank you.
Hello, my name is Richmond Kennedy Kwaku. I'm the director and co-founder of Plastic Punch. We are an NGO raising awareness using a citizen science approach, as well as coming up with sustainable waste management solutions. So to show you how beautiful Ghana is, because the next slides will be pretty disturbing, you are all encouraged to visit. Because of the absence of waste management solutions or systems in some areas, this is how the beach situation looks like. And in here, you can see a lot of single-use plastics with fishermen in collecting more plastics than fishes in some of the areas where we work. So this is how we started our project. It was as a response to this tragedy. Out of the 6 turtles we saw on a turtle monitoring session, 5 of them were dead. We could not scientifically diagnose what the cause of death was, but we felt there was a need to act. And we realized also, obviously, with a lot of plastics on the beach, we realized there was a link. So with this link, we had to bring the community in contact with the problem, let them be part of the solution by cleaning the beach, the turtle nesting beach, because turtles come to the same spots where they nest, and also collecting data on these marine pollutants. So we bring the community together and we provide the tools, reusable equipment. You see all the energy behind the punching. So plastic punch. That's why you see all this punching, 300 to 500 volunteers before COVID. Now we keep it at 200. So because we do not want to move all the waste from the beach to the landfill, we are not in that. We want to recycle as much as possible. We sort out the trash and record data on the different categorization and what pollutants are. We also find different things. So at COSIN, which is to build capacity in ocean sciences in Africa, a program, we found this Tetokara place over there to say that there's life and death all in coexisting on the beaches where we work. So we have plastic-free events to demonstrate to or draw attention to indigenous solutions that could reduce plastic waste in everyday life. So food is taken in leaves and drinks are served in calabash. Before the beach cleanup, volunteers warm up on the beach. Before going to the beach, we warm up. Aerobics, when the beach is clean, we play some sports. Reusable bottles are brought by volunteers to be able to, for refill, rather than using single-use alternatives or packaging. So children are not able to clean so much, so we propose to them different workshops. It comes in artistic workshop. We have gardening workshop, composting workshops, depending on the community that we serve. So this is some data on what we have collected over the period, 2 to 9 tons of trash collected on different beaches on different days. And this is a representation of some of the data and some of the areas where we work. Because we work beyond coastal communities, we have the theater and the series, which is for mass communication on TV to reach other targets other than the coastal community. So you can find this on YouTube, and it was sponsored by the UNDP in Ghana and the French Embassy as well over here in Ghana. Meet the Fish. It's a model we have to collect plastics for recycling, and we have piloting this and we're getting ready to upscale it, where we have this in different institutions for waste collection. We also have a game on Google app to raise awareness. We go to schools, the churches, we have animations, we plug at flea markets, all this as part of the edutaining tools that we have. We also have an app to collect data on sea turtles. A little bit of story before we go away. In March 2019, this is how the beach was looking. In January 2020, we made it very clean. And with COVID, and by the time we went back in September 2020, this is how it was looking. This is to say that we really need to stop the waste. It really stops in our home, and it really depends on our consumption habits and our lifestyle. So at Plastic Punch, we want to continue to raise awareness towards solutions. We want to be able to have litter traps, have technologies of litter traps where we can be able to categorize the waste in this trap and also collect data on them to be able to influence how decision goes in waste management in that municipality. Advocacy and lobby to reduce single-use plastic, capacity building for ocean sciences in Africa, especially for women in STEM. It would be great to have boys where we can be able, tailored boys where we can be able to have observational data and data on toxicity and on microplastic along coastlines in Ghana. So thank you very much, and thank you for your attention, and more punching.
Awesome. Thank you so much to our wonderful speakers, Morgan, Natalie, and Richmond. I see Richmond is here. Richmond, we have a quick question for you. So great job you've done so far. And as you say, I'm originally from Ghana, so I'm happy that they're doing some work there to get rid of plastics. But it looks like what you presented is more of curative measures. So the plastics are already there and then you get rid of it. Are you planning, or what strategies do you have to do more preventive measures to prevent the plastics from getting into the aquatic system? Thank you.
Thank you very much, Ben, and thanks for having us again. So yeah, that's a very good question. And so we have different strategies towards this. The first one is more of lobbying and advocacy, trying to direct policy direction. So that is towards putting a price on single-use plastics to discourage its use, for people to be encouraged to use more reusable bags. That is one way. The other way is also helping to build working systems for the waste management. So like the fish we showed is one of the models which are in different institutions, which we are piloting. Our mandate is specifically towards waste reduction and not recycling. However, because of the low recycling rates in Ghana, we have no option than to complement the systems. So we try to be part of these enabling environments to give people at home ways to be able to segregate and empower them to segregate and to be able to dispose of properly. The last one will be towards alternative packaging research that we are doing. Since COVID broke, since the outbreak of COVID, there's been a real rise in the single-use packaging from the data that we find on the beach. And we have started this research in alternative packaging, and we are looking to advance it further, where we want to come up with products from most of the post-harvest loss that we find here in Ghana. So talking of coconut, cassava, jatropha, sugarcane, or even the potential of industrial hemp or other vegetal-based materials. So this is the basic strategy, but the strongest one is empowering people to reduce, carry a reusable bottle, carry a reusable bag to the market, reduce as much as possible, and to get citizens to also be concerned about the whole situation. This is what we are doing.
Great, thank you so much. So to the community or the group that gathered here, we need to also brainstorm and see what alternative measures that we could take. That's, for example, existing instruments that we have out there taking measurements for us. How can we look at these? And then also, if not already being done, how can we add other measures or other tools to already existing tools to collect data on pollutants, not just plastics, but other pollutants that we saw in the talks and then others that we have in mind? How can we leverage that?
Is Natalie here?
I don't think so. I think both Natalie and Morgan are not here.
Yeah, they're not here. They might come to the next one or maybe not.
Yeah. But I could probably chip in. I'm also in the microplastic space. So the model to model microplastic advection is more following like advection of other properties in the ocean, such as heat or salt and light. So you need to understand the how ocean currents move. And with that also, you need to throw in the winds, the strength of the winds and all. And with that, salinity, which will come temperature weight together, will give you the density. So it's more of using, your base model is going to be more of advective properties. So the same way that you do particle tracking, where you can, for example, put a dye artificially in a model and then track the source, this trajectory and destination, that's a similar idea that you use to model plastics or microplastics. So you put that into the models and then you follow where they are. So in that case, you can tell when a plastic, for example, is dropped in one region, you could tell how long it will take and then where it will end up in. That's basically the idea.
Can I ask something about that? And also to Richmond as well, so to both of you. So would people, like would NGOs, such as Plastic Punch, use this information? Or do the efforts stop at the beach? You know what I mean?
Thanks for this question. So we use this data a lot that we find. We use this to influence the policy decisions, especially in the municipalities that are responsible for the waste management. So that is the first point where we use this data. We also plug our data into the SDGs 14.1 indicators for the country, for Ghana. So we work with the Ghana Statistical Service, we work with the EPA, and we also do brand audits. We have different types of data that we collect. So we have also like brand audits where we audit which brands are polluting. And this data we also use for different pressure points to support implementations of EPRs, extended producer responsibility in the country. However, we also would want to build more capacity in this space to, because our advocacy is strongly backed by data. And without the data, we are not able to really speak to the issues over here, especially how our governments work. So in the case of heavy metals, it's something we are happy to build capacity in because there's a lot of illegal mining, and it would be great to be able to track all these and the effects at different points of the coastline. So we look forward to further collaborations also in this space.
Yeah, thank you. So there's a question that was directed to Janice, and it says that does the atmospheric microplastics interact with the rivers on the ground and finally on oceans? Yes, they do. As she showed in the presentation, the atmosphere is one of the sources of microplastics. And once they get into the riverine system, they are vectored along with the rivers, and then they end up in the coastal areas and eventually into the ocean. So these are all factors that need to be considered when you're doing modeling of microplastics. So, so to the group, are there anyone studying pollutants, or do any one of you collect pollutants as part of the data that you collect from your instruments, or when you go out to sea, or to the environment in general?
I mean, so we do a little bit, but we just started, and I think it's more typical measurements that we would make, things like nutrients, and we collect samples for trace metals and things like this. And basically, it's the same oceanographic sort of parameters that we would always collect, but we use them to understand if they're elevated or not due to specific pollutants. So I think something like this is totally doable. I mean, I don't know if Dennis wants to say something else about that. Just turn on his camera. But it's nothing like buoys or using remote sensing or something like that.
Yeah, so yeah, thanks, Krista. So when you talk about trace metal and all that, I think there have been a lot of studies which showed how these come into the aquatic system. They affect organisms like fishes and all that. So you have trace metals in fishes and other organisms. With the scale that you collect them, do you think it's possible we could remotely sense these?
I mean, I think things like trace metals, you can't. I mean, there's no way. This is also what Martin was talking about. It's just impossible. I think that the remote sensing is useful for these things like winds and currents. I mean, and I think there were some other sessions and other satellite events that talked about you can detect some properties, some light properties of plastics, for example, with remote sensing techniques. But this I don't really know about. I don't know if anybody here knows about that.
Yeah, so how can we increase the volume of data that we get? I mean, since we can't do for remote sensing, but we still need to get a lot of data to be able to understand these things and how they affect the environment globally. So how can we network, or how to increase the volume of these data that we collect on trace metals? Or have you used models before to look at these, and how well are the models? How do you validate the information that you get from the models that are run to look at trace metal sources and how they end up in the environment?
Yeah, it's a good question. I don't know. Does anyone know?
Well, as far as some trace metals go, and I'm just thinking more about the remote sensing question, it does depend on them. And the ones that are super bioavailable, like iron, that are used in the plankton, there are indirect methods. There's a lot of people out there kind of working with Michael Barenfeld and his team thinking about the use of LiDAR and the fact that you have kind of a variable fluorescence that occurs that is in direct response to the availability of micronutrients and the stress that goes along with that. And so as you get this physiological stress response, you can see this variable fluorescence, at least in theory, from satellite LiDAR. So they're working towards that, and that gives you some kind of an indirect proxy of things like iron and even copper. But that's about the extent that I know of what you could do from space right now.
And also, just to chip in, I think there's an international collaboration called the GeoTrace that collects trace metal and other trace elements data, and I think this data is like open source, so it's readily available for anyone interested in. I think it's a global program. So, but I think there are just few countries, probably like the US and some other countries in Europe, that have some at a regional scale, but most of the data are like in the open ocean. So probably I'll drop the link in the chat chat box, so anyone interested can take a look at it.
Yeah, thank you all. Yeah, and there's a question. Megan asks if surface currents, if we could have surface currents from space, and how helpful will that be? And what would the requirements need to be? So Megan, I know you study a lot of currents. Do you use any I know of the Oscar product, but that some studies or some people who use that product have talked about how about the resolution, the fact that it's not too high enough to look at mesoscale processes and stuff like that.
Right.
Yeah. So what have your experience been?
Right. So the Oscar product uses winds and sea surface height to get a geostrophic and a direct wind kind of measurement of the currents. But there are efforts underway right now to develop a remote sensing of the currents, a direct measurement of the currents, the surface currents. And I think Luke is on the line. And I know that he was part of that, or he was on the line a little earlier. But in any case, that is intended to get direct measurements that are high resolution, and that they would be right at the surface, not kind of at 15 meters depth. So, but I think what they would really want to know are, what are the requirements for a clean ocean? How close do you need to get to shore? What is the horizontal resolution that you need, and the temporal resolution? I mean, we can talk about that at the next session, but in terms of the model, the tools that you were talking about earlier today, what's needed to run the model?
Yes, indeed.
Yeah.
Yeah, great, thanks. Yeah, and there's a suggestion from Christoph. There's a poster that that talks about direct measurements of the ocean currents. So let's please all take a look at it and can learn some more. Yeah, and then there's also a post from Maria linking to Van Sebille in Utrecht. Yeah, he's done a lot of studies on the transport of plastics and microplastics in general. But a lot of it is using reanalysis. And I know one of the things that he and other people have suggested is having inputs from in situ measurements and satellites to be able to enhance the validity of those models. So there's a long way for us to go to getting these in situ and satellite measurements to do this.
Yeah, I mean,
maybe.
Sorry.
Go ahead. Go.
Well, I was going to say this is an expensive solution, but what we've been doing in the United States anyway, and other parts of the world too, is the high frequency radar for surface current measurements. This is a coastal solution. You can get out many kilometers, but it's not a global solution. And but we are talking with folks here in California about the fact that we already use those radar data, the vectors that we get from that through the calculation to do the kind of Lagrangian particle tracking, just to at least look at things in a particle moving advection sense, because we already do that for pollution plumes, where we have a lot of pollution, for instance, coming off of the Tijuana River. So we do this kind of forward model to show where the pollution might land on the beaches. And we're thinking about how to do the same thing for plastics. But again, this is a coastal solution, and it's a very expensive one.
I was just going to say, maybe this is a discussion also for the next session. So we have to take a break now in a few seconds. But I think also getting this existing data that would be applicable into the hands of people that need it is a topic. And how do we get those people all around the table? And maybe this is something that Oasis for Clean Ocean could target. And maybe therefore we can bring ourselves into the next session.
Yeah, that is very true, Krista. Yeah, I think that a lot needs to be done by the community coming together to put together this information. And Krista posted a paper by Isobe, which was recently published, and that does a good job of compiling microplastic data from a number of studies. And I think, that's a paper here. And yeah, it's have a very detailed data set. So if you can grab a copy of it, look at it, and it has some suggestions also, because in what they did was, after compiling the data, they tried to harmonize it And in so doing, they use some wind product from satellites and all. And they highlight some of the things that we need, which Megan also mentioned, the currents. Anyway, I think we're running out of time. We need to take a 5 minutes break and then continue with the next session. But thank you so much. It's been an interesting session. All right, see you all soon.
I'm the moderator. Oh, thank you. I'm the moderator of this session. And so I'm Krista Marandino. You saw me already a lot, so I guess I don't have to really introduce myself except to say that I'm a biogeochemist who's recently started getting interested in ship emissions and the effects of shipping emissions, specifically scrubber effluent, on biogeochemistry and trace gas exchange. And so this is part of why my interest is here. And also within the realm of SOLAS, I participate in the SOLAS Science and Society initiative. And I think that this is also very fitting within this clean ocean theme. And of course, I'm an Oasis co-chair, so I'm involved deeply in the Oasis project. So we can, without waiting any longer, we can start the talks for this session. Great.
Welcome to join a discussion on how observations and the understanding of air and sea interactions can support a clean ocean. My name is Miao I'm assistant professor from Nanjing University of Science and Technology in China. My research interest is marine organic geochemistry of anthropogenic organic pollutants. Today, my topic is about polycyclic aromatic hydrocarbons at the air and sea interface. pHs are avoidable byproducts of the incomplete combustion of organic materials, such as coal and petroleum and grass, straw, wood, and other biomasses. They are often considered typical anthropogenic organic pollutant. pH adversely impact human health and ecosystems and are known to persistent in the atmosphere. It has been proved that temperature and humidity dependent variations in effective viscosity of organic aerosol shield pH from chemical degradation. Therefore, pHs can be transported over long distance, even participate in global transport, just like persistent organic pollutants. So these compounds can be found almost anywhere in the ocean, even the polar regions. In the open ocean, the exchange processes of pHs at the air-sea interface include atmospheric deposition, volatilization, and absorption. Overall, the open sea shows a net absorption of pH at the air-sea interface. However, in the coastal area, the air-sea exchange characteristics appear to be different from the open sea. In my previous study in the Taiwan Strait and the Magnum Sea of China, we found the low molecular weight of pH presents the net volatilization process, and the medium and the high molecular weight pH showed the net deposition. Overall, because of the predominant components of low molecular weight pH, the fossil fuel-derived pH presented the net volatilization process at the air-water interface of the Taiwan Strait. Compared with the open sea, surface runoff and oil spill input abundant pH to the coastal ocean, which increased the fugacity of pH from sea to atmosphere. The number of publications and citations is increasing year by year. If we summarize the results of the studies in different oceans, we can explore the driving mechanisms for human-derived pHs to participate in their global cycle. Therefore, the establishment of a global air-sea exchange observation network can effectively assess the impact of human activities on the ocean. In our previous on-site investigation, we found that there are many buoys on the west coast of the Taiwan Strait in China. I believe that there are also many buoys along other coasts around the world. If possible, these coastal buoys can be used as an ideal sampling platform for air-sea observation of pH and other pollutants. Further, we can establish a global database of air-sea exchange of organic pollutants. On buoying sampling platforms, passive sampling can be an ideal sampling method. The established passive sampling methods of pH and other organic pollutants in the air and seawater have been proved to be feasible. In summary, to establish a global air-sea exchange network for organic pollutants, the standardization of sampling methods on the buoy platform is essential. Through comprehensive international cooperation, the global air-sea exchanges and their fluxes of organic pollutants can be observed. Once the global observation network is established, we can gain a comprehensive understanding of the mechanism by which human activities affect coastal oceans as a response to the climate change. This will help to develop different emission reduction strategies in different regions of the world. That's all. Thanks very much.
Good morning, good afternoon, and good evening to everybody at Oasis for a Clean Ocean. My name is Letícia Cotrim da Cunha. I'm a professor for chemical oceanography at Rio de Janeiro State University in Rio de Janeiro, Brazil. And I'm here to talk about CO2 in the ocean and ocean acidification. And this concept of ocean pollution, although CO2 is a gas that occurs naturally in the ocean, we can consider it as a pollutant because it's been changing the way the carbon chemistry in seawater is changing the equilibrium, and it's affecting the ecosystems and the organisms, the marine organisms, especially those who produce calcium carbonate structures. And talking now from the point of view of the way ocean acidification is seen, especially in coastal areas, and the experience from Brazil and from Latin America altogether, especially the Atlantic countries, mainly Uruguay, Argentina, and Brazil, is that the concept of acidification is still somehow abstract. But it is important, and people are getting more and more aware of the importance of observing the ocean seawater properties or the ocean essential variables, and that observing pH and dissolved CO2 and the other parameters is an important way to monitor how the ocean is behaving, and especially for the coastal areas, and especially for the coastal areas where you have shellfish farming, oysters or mussels, for instance. And this is an important activity in many areas along the Atlantic, the South Atlantic coast. So what I guess the next step, the important next step for expanding this idea of how important it is to monitor ocean acidification and to monitor the ocean variables and understand the change is to implement either by governmental programs from science academia, but it is also important, and I would like to make a call for the fisheries and aquaculture industries to also monitor the waters they're using, or if there's aquaculture offshore or near shore. It is very important to understand what's happening in seawater. And the more data we have, and the more data available to everybody, it's very important not to keep the data for yourself, although you're measuring. it's very important that the data is open and the data is collected using the best practices for ocean variables, and in this case for the CO2 and acidification variables. So that with a bigger database and an open database, and I advise everybody to have a look on the Global Ocean Acidification Network, the GOA-ON network. And we have all tips and the methods, and you can also ask for help to have a look on how to measure, how to correctly measure, so that we can compare all the ocean acidification, pH, total CO2, partial pressure of CO2 in seawater, and any other parameters. It's very important that everybody is measuring the same way, using the same methods, so you can compare and we can evolve on the monitoring, and also it's going to be much easier to detect the most vulnerable areas, for instance, where you have upwelling or seasonal upwelling, or if there's a combination of eutrophication and acidification. This is very important to have good data. So this is my plea for going further into a clean ocean for the ocean decade. Thank you.
Okay, so those were the two talks for how to have an oasis for a clean ocean. And I think we don't have the speakers here, correct? But I think this should not deter us. I think here the topic, so if anyone wants to talk, I'm happy to hear what is needed for Oasis for a clean ocean. How can Oasis support a clean ocean? And for me, this means a global network with ideas about capacity building, fair data, interoperability, and best practices, how to interface with the UN decade, and how to build a global network. So what do we think as a community we need to do to support a clean ocean? Or does anyone have any questions first? Please. Okay, Matthew, go for it.
Hello. It's one of these things about best practices. So somebody mentioned in a talk, or somebody mentioned after a talk a while earlier that GeoTraces has excellent trace metal sampling techniques, and they have what is known as a cookbook. This cookbook is only applicable to potentially 6 institutes, maybe 7 institutes in the world. That is not globally open. So, and also it's applicable to open ocean, which yes, we're interested in, but many of the participants here may not be able to reach the global ocean. So having best practices which are not watered down, but usable for a greater majority of the scientists is probably a lot better for producing the data which people require, rather than having highly stringent, strict practices which close the ability to collect the data and then limit that. So best practices for everybody is probably one of the most important aspects.
So interoperable best practices, basically. Good. I see there's something in the chat. Jan, please feel free to talk if you would like.
Go ahead.
Oh, so hands. I see lots of hands. Okay, Uta, sorry, I didn't see that. Uta was first, I guess.
Okay. 2 questions, actually. One is microplastics in the ocean. I'm not a specialist in the observations, but I do understand that as long as they're big enough that visually one can identify what it is, it's okay. But as soon as they become sufficiently micro, that's not possible anymore. It is a real challenge to identify what it is. So I'm interested to hear of how developed the sampling regimes are, and then the actual analysis well, maybe links to the best practice as well, or some sort of cookbooks of how this should be done, so that data interoperability, intercomparable. And the other question is to the ocean acidification. And I see that Jan is here. In terms of strategies, because the resolution and frequencies are different between the open ocean and coastal, which has been mentioned. Is there a strategy document that outlines at what frequency and resolution it should be measured in which areas?
So one technical question to the microplastics community and one technical question to the ocean acidification community. Is there anyone in the audience that can answer Uta's questions?
I think Jan's going to answer for OA. She's mute.
Yes,
Great.
I can answer for OA,
Great.
but if somebody wants to take plastics first, I'm happy to yield.
Well, why don't you go ahead and then we'll see if someone warms up.
That sounds good. So thank you, Uta, for the question. And I didn't write down the name of the speaker. What was her name from?
Leticia?
Leticia, yes.
It
was great to hear her talk. And so I'm one of the co-chairs for the Global OA Observing Network, Go On. And we, as I put in the chat, have a UN-endorsed program, OARS, which stands for Ocean Acidification Research for Sustainability. I put in a couple of links. The first one is the overview and has our outcomes. The second one actually has some documents that might be useful. And sometimes people don't realize there's another tab there. So that's why I put them in both. And you can see that our outcomes for OARS are really encompassing on the science of the measurement of ocean acidification to enable the scientific community to provide data and evidence of known quality, and that we have to do that through capacity development and mentoring and facilitating data sharing, as Matthew mentioned. And so I'm flipping back through the web and the Zoom, sorry. And so as well as other outcomes that are focused on getting that information to society. So we're really excited to be launching OARS and wanting to have partners, developing partners. So I'm excited to be on this Zoom with Oasis folks. And what I'd like to say, and also to answer Uta's question, but I'll come back to that in just a moment, is that I feel like some of the best success that Go On has had has been to really reach out to people globally and do that through capacity building, whether it's mentoring or trainings, but also the creation of regional hubs. So there's OA Africa, there's an Arctic hub, there's a newly formed Arctic hub. There's Laoka was the first one in Latin America, and Leticia is part of that. And that organizing principle has been really good. But to Uta's point, you also need to have leadership on how are we going to do this? And it became very clear early on that there's different needs for OA data. Some of it is documenting it. And so it has to be that what we call climate quality, that really high level quality that some labs are capable of to document the trends. But in coastal systems, or if you're trying to understand biological responses, you don't need as high of a data quality objective. And a lower one can be defined, which we called weather, that's perfectly suitable. But the point is it has to be documented as to what the data quality is. And so we have on the Go On website, and I'll put the links there when I'm done talking, both the initial plan on requirements and then a more recent implementation strategy that has some of this information. It's not perfect. And I think that the most important thing is, to continue to stay involved, and Uta has been from the get-go, with Go On to help continue to define these things. And what we really want to do is kick it up a notch through our ORS activities. So we currently have a call out to anyone who would like to be involved we're going to establish a working group around each of our outcomes, those 8 outcomes that you see, or 7, or however many there are on the website, and get some focus on this. And we're really happy for partnerships. So I think that's what I'll say, and I'm happy to ask more or answer more questions. Thank you.
So did you also say what you wanted to say when you raised your hand? Sorry, I didn't quite.
It was.
Yeah, okay,
What I wanted to call attention to is the ORS activity.
Okay,
and yeah, thank you for checking with that, Krista. Yeah.
So before we go to the plastics, so I think Christoph, if he's happy to answer Uja's question about the plastics, I think he put something in the chat. But right before that, I want to just say, it seems like somehow the communities, again, need to get the information to each other, I guess. I mean, and I've been, can you say jealous a little bit of this Go On? I've been looking at it a lot recently, and I feel like there's a ton of information there. And I really enjoy going to that website, but I wonder, does everyone know that they can go to that website? Or does the CO2 Plus community go to the Go On website, I guess is my question. And if not, how can that be facilitated? Does anyone have a thought? Or, I mean, Uja, did you know about the Go On stuff before? Yes, okay. So there is communication then amongst the different sort of communities related to carbon and ocean.
I mean,
But if not, we can help.
Yes, but I mean, it will not do any harm to encourage that more. I can, I mean, as soon as somebody works on ocean carbon, it should be linked to ocean acidification.
But is it like that?
Yeah, I mean, you hear I'm hesitating a little because I don't actually know how widespread it is. So
okay.
Further encouragement is always positive and useful.
Mm-hmm. Okay.
I would definitely agree with what Uta just said. I feel like there are some linkages, but it's not as strong as it could be, and it's not as widespread as it could be. So I think, as she said, further encouragement is useful. And I'm, as Go On co-chair, I'm really happy to offer any, services or talks or whatever connections, and to hear suggestions on what would be useful on that. I'm very happy to hear that.
Okay, thanks. So Christoph, would you mind answering Uja's other question about the microplastics, or what do you think to that?
I'm sorry, I have a bad connection. And can you give me back the flavor of the question about plastics and satellite?
Do you mind, Uja? Can you re-ask?
My question was about the analysis of microplastics, or rather the identification of microplastics. I'm not a specialist in it, but I understand that it is very difficult to identify it. So I'm wondering how, is there sort of some agreement, or again a cookbook, a best practice of how it is identified so that different studies are intercomparable?
Yeah, people are developing some protocols, especially for samples collected along the beach, but not really on open oceans. And what do you mean exactly by identification? You mean the type of polymer, or the type of the size, or the color, or the fraction of plastic?
No, the actual chemical composition, because without that one cannot identify what it is and where it comes from.
Okay, so I'm not sure if the polymer types are really considered right now. They are more classified as fiber or no fiber, something like that. But I don't know if always all the studies do not make the effort to put the polymer type. And it's probably a recommendation that can be done, at least for samples collected along the beaches and on ground, and probably also at the surface of the oceans, but it will be more complicated, I think. And of course, it's not possible to have such kind of separation in terms of satellite measurements, especially for microplastic, because most of them are not really at the surface, where we all know that the satellites are looking on. And most of the time, due to turbulence, they are inside the first meter depth. So it's very complicated to have some kind of measurements of this.
Yeah, and
Maybe
just to add, yeah, sorry, go ahead.
Well, I was just going to link to it because Ebenezer, you were asking earlier whether satellite data can help. I think in microplastics, this is the answer, that it can't. It's a different type of analysis to identify whether it is a natural particle or whether it is actually an artificial plastic.
Yeah, thanks. Just to add, the way they do the identification of plastic, currently a lot of studies, they use FTIR, spectroscopy techniques, but that doesn't give you, like, as Christoph mentioned, the specific type of polymer. Maybe those would be how chemists do it, and I have no idea. But on the remote sensing part, the reason why currently we cannot sense plastics, microplastics from space is because of the size. Because by definition, they are typically 5 millimeters or less, so very small. So currently, even the studies that look at plastic, which are more macroplastic scale, tend to look at those near fronts, water fronts, where you have plastics being aggregated, or near estuaries, the beach, where you have them aggregated. And for that, they're using some of these European satellites that fly over both land and ocean. So as you get to the land-ocean interface, it's able to resolve those particles. But for microplastics, it's currently not being developed yet. So there's the need to first identify the spectral signatures of microplastics and be able to tell that this is either microplastics you're looking at or something else. And that is where the research community is at on this front. Thank you.
Any other questions or comments from folks in the audience? So Clarissa wrote something in the chat.
I did. I can repeat it. Speaking from a place of total ignorance, I'm just wondering why we think that the floating plastics aren't discernible from space. I know particle size is a constraint, but we look at so many scattering objects in particles in the water. We even can differentiate PIC from POC. So does anyone here who knows much about these differing refractive indices, could they say something about that?
I have no idea, but we definitely.
As I mentioned, Clarissa, it's more to do with the sizes, because the microplastics especially are very tiny, 5 meters or less. So we don't have that high resolution satellites yet that could be able to discern between plastics and then the water environment. But there have been some that have looked at such studies, but those are more when you have the plastics aggregating, so they become larger masses. And by that, then you can see the signatures very well. But individual plastics in the water, and come to think of even microplastic, that is very difficult at this stage. Mainly because of the size.
To add to, sorry.
Got it.
Just to add to Eben, also because plastics sink when they get into the open ocean, it's usually very difficult to track them because most of them sink, except those of them which are aggregated by the ocean currents. So it would be one of the reasons why there's that difficulty in tracking this. I did also see one gentleman in San Diego for the AGU Ocean Sciences meeting, and he had a paper where he was he's trying to come up with an underwater tracking device which would be able to record microplastics, but it's really at the emerging stage of development, what we saw when we saw it in February 2020. I forgot his university, but otherwise such technologies would really work well, this underwater, and also it will come with its own complications. but I am hopeful that we find a way around the satellites because it would be a very easy way rather than all the reliable institute source of tracking these microplastics at the moment. This is the only most reliable way, I would say.
Yeah, good points. I was just thinking, you know, it gets back to Natalie's talk and the modeling methods and the inference, because when we do the particle size distribution stuff for plankton anyway, it is a lot of inverse modeling that goes into that using the remote sensing reflectance that you do get. So you've got to kind of back your way into what's happening with these very small particles.
Okay, so I think we have to stop now and take a short break. So just to know what's going to happen now. So my plan is to come back with a very quickly thrown together take-home set of messages and summary. And I think it will only take a few minutes for me to say the words on this slide that I put together now. So what I hope for this last 10 minutes or so is you guys can speak up when you think a very important take-home message is missing or something is more important than another. And I noticed that some of our questions didn't get answered. So I'm happy when you guys just throw out some answers to some of the questions that we had for the sessions. So I think the discussions have been great so far, and I don't want to interrupt discussions to ask specific questions, but now's our chance to maybe get some quick answers. So I ask for you to take 5 minutes, come back, and let's have our last little discussion for 10 minutes. Thank you.
Okay, but Krista, if I want to stay on and ask a question, I can keep talking. Okay.
Of course. And I'm going to go into my little picture.
Okay, very good. Because I have a question
and that means you can't trap somebody who then cannot go to the bathroom. I hope you realize that.
Please take a little time if you must. But this is, I just wanted to follow up a question with Jan, if you have a moment here.
I'm good, yes.
Are you good? Okay. So with the peer-to-peer, is that a go-on program, or is that a separate partner that you are working with?
No, that is a go-on program that we started in 2016, and it's run through Go On, so you can sign up either to be a mentor or a mentee, and you put your need, and there are some small scholarships available with that as well. Yeah, no, we've had some really good success with the program.
So kind of the philosophy that Oasis is taking is that if something is already out there, we don't want to, reproduce it.
Right.
We want to amplify it and help it and kind of put some, put all of our passion towards that's already working.
Yeah.
And so is that peer-to-peer program something that Oasis could also participate in or partner with, or?
Yeah. Well, I don't want to overstep my bounds because I'm a co-chair, but I would say absolutely. And so I think the key is to have the discussion. But I feel that, Oasis is, the overlap is strong with Go On. And so it would make sense. And I think, as we are recruiting, we can add that element, and there's just a lot of things we could do together. So Megan, let's definitely follow up on that. But my reaction is that it makes a lot of sense. And we agree, we're never intending to be an exclusive club. And I think the more we can work together, share strategies, share successful things, it just makes a ton of sense.
Right. Okay. Yeah, so maybe when Krista comes on with the summary, we can also do some handshaking between Go On and Oasis.
That'd be great. Hey, and this is perfect timing because we have a co-chair and secretariat call this week, and then we have our executive committee meeting in, it's the week that's half November, half December. So we can definitely have some discussion of this sooner than later. So that's good.
Okay, that's great.
Yeah.
And
I have a hard stop at 10 o'clock. Well, the top of the hour. And so I will be bouncing off probably even a minute or two ahead of time, but know that I'd really like to follow up on this.
Yeah, well, we're also going to have another set of this at 5 o'clock in our time in Seattle. So anyway, here we go.
Okay.
Yes. So I wonder, first of all, sorry to break up your conversation. Please continue it later. So now if does somebody mind sharing this PowerPoint presentation that I just quasi finished, or should I do it myself? Does anyone? Cassie, will you do it, or should I do it?
Cassie, do you have the link? I can send you the link quickly.
So, but I can also do it if it's easier.
Yeah, up to you. I don't have the link, so
okay, I do it. Let me just do it. Right.
Okay.
Oh, so there we go. Jessica did it. Thank you. Can you put it on presentation mode, please? Okay, here we go. So, like I said, a quick and dirty take-home message summary of action items. Can you go to the next slide, please? Okay, so sorry, it's a lot of words. Major take-home messages. So we had a cumulative effort or a group effort of writing notes in the background during the discussion. And so what we thought about for major take-home messages are that there are multiple transfer processes happening. So it seems like air-sea interactions can bring pollutants to the sea surface, but can also transport away, for example, to the atmosphere or somehow around the ocean and then to the atmosphere, the impacts of these pollutants. So the transfer processes go in both directions, but they also go between sort of the natural environment and the societal realm. And this is very clear, it became extremely clear in Lydia's talk, that the effects of these sort of pollutants and these pollution events on the society are extreme. And maybe it's sometimes, I mean, I think also like Morgan said in her talk, we think about the plastic floating on the surface of the ocean, but these red tides and these harmful algal blooms and the deposition of PAHs and these things, they also really affect these coastal communities, and it's important to keep them in mind. So it appears like we need early warning systems for things like harmful algal blooms. I guess it's not the only thing, and mitigation strategies, and that the needs for human and technological capacity sharing are very, very dire. So those were the major take-home messages that I thought of and that Jessica thought of, and Megan and folks taking notes. Does anyone think that we completely missed something here? Good, so I keep that. But we had some questions that we wanted to answer. And now I would like to hear quickly if anyone has a thought. Is there a set of emerging pollutants that we don't focus on enough? So we know we thought about ozone, we thought about things like excess nutrient deposition, things like heavy metal deposition and PAHs. In the back of our mind are things like oil spills and ship emissions and plastics. But is there something that we completely miss? So I see some in the chat. Good, I will take them from the chat later. Thank you. And I think the other question here was, what is the priority? So do we have to think in terms of a priority set of pollutants and not just keep in our mind like this laundry list of pollutants? Does anyone have thoughts on what the priorities are? No deep thoughts. Okay, some things coming in the chat. Okay, you can continue to write in the chat. So I will continue. If you think of more, please write them in the chat. Okay, so the techniques for observing and understanding marine pollution and hazards. The major take-home messages. There are many types of pollution. Some of them are detectable with remote sensing techniques, etc. Some are not. So we have to develop a range of methods to detect them. And many times there's issues of scale. So if we're talking at the coast, if we're talking about modeling, if we're talking about remote sensing. So we heard many times today this issue of scale that kind of needs to be tackled, I think. And it seems what is interesting to me, which I guess we know it, but still it struck me, was that things like raising awareness and building capacity are also tools. So these are tools that need to be used and developed and brought into communities. And so we heard a little bit also that Goa On has these regional networks. And we heard also from Richmond about Plastic Punch so he's the one that said he needs to raise awareness and build capacity and use it as a tool. So I think this is an important point. So we see that models are existing tools that can be used in new ways. But again, it seems like the challenge is getting data into the hands of the right people. So we have to work on that. It seems like we can scale up to remote sensing techniques, but not for everything and not immediately. So obviously there's still much more work to do. And what is missing and needs development didn't get really discussed very much, but one point that got brought up by Megan was that we need information about requirements. So the different communities need to talk to each other. So the observationalists and the remote sensors need to talk to each other about what kind of requirements are needed for things like remote sensing. If I missed anything, please speak up or write it in the chat. Can we go to the next slide? Because we're basically running out of time. Okay, so Oasis strategy for a clean ocean. My take-home message that I did not write here is that it seems like there's a lot Oasis could do to promote and support a clean ocean. So that's one of my major take-home messages. But it seems like one big point is that global observations are needed using existing networks. So we heard it in the PAH talk from Meolai Yao, that there are these existing networks that can just be outfitted with the appropriate sampling or sensor technology to actually help make some measurements of these pollutants. So this is definitely something to be explored. And that a push is needed for more governmental monitoring of things like ocean acidification. And we heard the word lobbying, again, also from Richmond in session 2, that this needs to happen. So this is something that an Oasis project can participate in, I think. And obviously best practices. This was coming up again and again and again. This is definitely on the radar of Oasis. We definitely need it. And so I think we don't have to go through these 5 theme teams or any of these questions, but one thing that came into my mind, and I guess it would be nice to get some input on at some point, is what is the range, like what is the priority? Is it more data that is needed, or is it more capacity building that is needed? So I guess if we could think a little bit about that, it would be interesting for the Oasis community to know. So I am an observationalist and I always think we need more data, but I think it sounds like there's a lot of data out there and we need to like get it in the hands of the right people and figure out the right ways to use it and then develop capacity with our stakeholders. So that is my take-home message. So thank you everyone for joining our airing here. And there is this Gather Town poster session. So please, can somebody put it in the chat? If you have time still, please come to Gather Town and talk to the folks and look at the posters. And there's another airing of this event at 2 o'clock CET. So if anyone wants to join again. And thank you everyone for coming.